Given some x sub t, y sub n, and some sample frequency, find h sub z, h sub w hat, and then evaluate the h w hat at relevant, w hat values. So I already covered how to turn this into x sub w hat, so I'm not going to cover that. If you need help with that, please watch my previous videos. It looks almost identical to this, but it'll have a 7 at the top, and it'll look like this. I'll go through all of this work here, and it'll look just like this. So I'm going to snag the values for x sub w hat from this, just so I don't have to redo this, and this video isn't as long. So my x sub w hat is just this. So x sub w hat equals 5ej0 at w hat equals 0 plus 2ej0 at pi over 2 equals w hat plus, I believe it was 5. I want to double check. I don't want to give you wrong values. Plus 5e to the j pi over 2 at pi. 5e to the j pi over 2 at w hat equals pi. So this will come into play later. We're not going to use that right now. If you need help solving that, please watch my previous video, but we're going to start from here. So the very first thing is we need to find h sub z. Do not use long division. So you'll see exactly what that means in a minute. So first we have to do is it's going to come from the y sub n minus 0.1 y n minus 1 equals x sub n minus x of n minus 2. Remember that h sub z equals y sub z all over x sub z. So we need to convert these into y z's and x sub z's. And that's really easy. For the first one, it's just y of z. The second one is, so y of z is z to the negative 1. What I want you to think about it is y sub z or y sub n just turns to y sub z. But you add a delay in the z domain for how many is delayed. So it's delayed by 1 because 1 minus 1 equals 0. So it's delayed by 1, so you'd have a z to the negative 1. And then your amplitude up front just stays exactly the same. Don't worry about that. Same thing for x of n. X of n turns into z minus x of z, z to the negative 2. Perfect. So I'm going to factor out a y sub z and factor out an x sub z. So you'll see that here. Y sub z, 1 minus 0.1, z to the negative 1 equals x sub z, 1 minus z to the negative 2. Perfect. Now I'm going to divide by x sub z on the right and divide by 1 minus 0.1 z to the negative 1 on the left. So I should get h sub z equals 1 minus z to the negative 2 all over 1 minus 0.1 z to the negative 1. And this is how you would find h sub z. The reason it's saying don't use long division is because, yes, the bottom is smaller than the denominator, and normally you would use long division to get something nice to clean out. We don't want that. Leave that alone. It says don't do it, so we're not going to do it. So let's see what B is asking. Well, B is asking solve h sub w, solve using Euler's equation. Okay, so the first thing we do is we replace all of these with, so h sub w hat equals, so we're going to have 1 minus e to the negative j 2w all over 1 minus 0.1 e to the negative j w. Now remember, e to the negative j, blah, 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 it each has its cosine and sine attached to it. So I can write this as 1 minus, and then I'm going to have a cosine of, it should be negative 2w hat plus j of negative 2w hat. Oh, I'm sorry. Sine of negative 2w hat, all divided by 1 minus 0. Oh, I'm sorry. 0.1 times the cosine negative w hat plus j sine of negative w hat. Now what I can do is I can combine like things. So what I mean by that is I can say this is 1 minus the cosine of negative 2w hat plus the j of sine negative 2w hat. And this one on the bottom is 1 minus the cosine of negative w hat. So there should be a 0.1 in front of this. I forgot to distribute the 0.1. Let me go ahead and clean that up. And this should also be a negative up here because that negative gets distributed in. Let me clean that up. So 0.1 cosine negative w hat, and this will be minus 0.1 j sine negative w hat. Perfect. Equals h sub w hat. This here is our value. Now let's look at C. What is C asking us to do? Evaluate h sub w for the relevant w hat values. Well, that's where the x sub w hat comes in. These are our relevant w hat values. The next thing I want you to consider is what is going to be easier to use? Is this going to be easier to plug in w hat values into? Or is this going to be easier to plug w hat values into? If you prefer the top one, you go ahead and use the top one. I have no issue with that. We're allowed to use calculators, so I'm going to use the top one. If you feel comfortable using the bottom one, all you send it. But I'm not doing that. So I need to consider that h sub w equals, what was it? 1 minus e to the negative j, 1 minus e to the negative j, 2w hat, all over 1 minus 0.1 e to the negative j w hat. Let me make sure that's correct. Yep. Now, remember, I'm going to write this down. Our x sub w hat equals 5ej0 at 0 w hat plus 2ej0 at pi over 2 w hat plus 5ej pi over 2 at, I believe, pi w hat. I want to double check that before we continue forward because I don't want to mess anything up. Yep. Okay. Remember, to evaluate it, we are going to look at these values here. So 0, pi over 2, and pi. And we're just going to plug that straight into here. So I'm going to get h sub w hat equals 0 gives me 1 minus e to the negative j 2 times 0 all over 1 minus 0.1 e to the negative j 0. Well, this goes to a 1 and that goes to a 1, so this value here should be 0. 1 minus 1 is 0. Looking back at my notes, we do have to use this formula. This is correct, by the way. This is 100% correct. I believe we can keep going through with this, but I believe it doesn't help us too much. And I believe that we want to use this, especially as we start moving forward. So let's start with this one. And so we're going to get 1 minus, so h sub w hat equals, and we're going to look at pi over 2, equals, so we're going to plug in pi over 2 for each of it. So we're going to get 1 minus the cosine of negative 2w hat. So we're going to have 1 minus 2, I'm going to double check that. 1 minus the cosine. 1 minus the cosine of 2, and my w hat is pi over 2, minus j sine, and this is 2w hat as well. It is negative 2 pi over 2 all over, and this is going to be 1 minus 0.1, 1 minus 0.1 cosine. This is a negative, by the way. It should be negative w hat, so negative pi over 2 minus the j of sine negative pi over 2. Let me double check that. And there's 0.1 in front. 0.1. Okay, well, let's look at this. The cosine, this is just going to turn into a negative pi. This is going to be a negative pi, and that'll stay the same. So I'm going to have 1 minus the cosine of negative pi is 0. So I'm going to have 0. Minus j. The j of negative pi, negative pi is here. So this is 1. Negative 1, actually. Minus negative 1. J sine of negative pi is 0. 1 second. That's 0. So, then I have the bottom. Stop. Then I have 1 minus, well, the cosine of negative pi over 2 is here, so that's 0. Minus, and then the sine of negative pi is negative 1, so I have plus 0.1j. So, h sub w. I'm only going to do this for 1, by the way, because this gets extremely repetitive very, very quickly, and we don't want to do this. This video will be like an hour long. So, we have to consider now, we're going to have 2 minus j, well, it's 2 minus j, 0, all over 1 plus 0.1j. We now need to convert this into exponential form. To convert this to exponential form, I'll just do this for the top really quickly. You're going to have your magnitude is your a squared plus b squared, where this is a, that's b. You're going to get 4 squared plus 0. You're just going to get 4 up front, e to the j, and then you have your arctangent of 0 divided by 2. And you do the same thing on the bottom. You're going to have the square root of 1 squared plus 0.1 squared e to the arctangent of 0.1 divided by 1. 1. It's not letting me do it. I'm sorry. 1. I'm at the edge of my paper. That's why. So you'll just get this value for each of them. You're going to solve it. If that's literally this whole thing. Is you're just going to do that over and over and over and over again. But I don't have a calculator next to me right now, and I don't want to start computing all these. So that's all you're actually going to do. But there's a J in front of this. So go through, find each of them, and this will be a 2. Go through, find each of these, plug in your calculator, get your actual answer. This final part is literally just, can you plug numbers into a calculator? So remember, your magnitude equals the square root of a squared plus b squared, and then it's going to give you that's your real number is your a, plus jb, your imaginary number is your b. I can put that imaginary. And then you're going to have e to the j theta, where theta equals the arctangent of imaginary divided by your real. That's literally just this. That's all you're doing. You're literally just plugging this in, finding out what your reals are. You'll obviously divide them, and then, when you're going to get an e to the j theta divided by an e to the j theta. I'm going to call this theta 1 and this is theta 2. This is equal to e to the j theta 1 minus theta 2. So you just remember that. That's his entire problem. If you really need me to go through it, please leave a note in the comments. I am more than happy to go through it with you. If you need any more explanations, let me know. But I believe we covered everything, so I'm just going to recap really quickly what we did. X of t, it's our W hat. Please watch our original videos to find where you go. To find your W hat, remember you take your Y sub n's and your X sub z's, turn them into Y sub z's, X sub z's, factor an X sub z, factor a Y sub z. You get Y sub z over X sub z gives you H sub z, and then you have these values here. And that is just finding H sub z. It said do not use long division, so do not use long division. Next, we're going to use Euler's formula. So we're actually going to factor this out into its individual components. And once we get into its individual components with its real part and its fake part, you're going to combine your reals, combine your likes, and then leave it alone there. And then the next thing you have to do is you have to determine where these are all these. Those are where you're evaluating it. You're going to evaluate 0, pi over 2, and pi. The first one, it just was lucky. It worked out that we can use this formula here. In reality, you should be using any formula you want. But because we use this formula here, we do want to use this formula moving forward with the rest of our equations. And I showed you how to do the rest of it. The rest of it is plugging into a calculator. But please, leave a comment if you need any help with the plugging in the calculator portion. I'm more than happy to help with that. Thank you.